Hello everyone, this is a beautiful question of the vertical circular motion. Question says there is a cart of mass m. This cart has the mass capital M. It is released from rest from point A and then it goes on a frictionless track as shown in this diagram. Cart goes like this. Okay. Question says this part is the semicircle, part starting from D and then up to C. This part is a semicircle and the radius here is given as R. The height of point A is h1, the height of point B is h2 above the ground. And the car is never leaving the track. This cart is never leaving the track. Then which of the quantities are of no use? The answer would be obviously this M. If you remember the vertical circular motion, you might be remembering the formula for the critical speed, the V minimum. And in that formula of the critical speed, the mass doesn't appear. What I mean to say, for this point B, here is the track and we draw the free body diagram of this cart. This cart has mass M, so here is mg. Here the cart's speed is minimum. Let's say we call it V minimum, and just at this point for the critical condition we are taking the normal force to be 0. There is no normal force on this cart, and if the cart crosses this point B, then later on it can easily go along the track. Okay, now this mg is the centripetal force, and formula for the centripetal force we already know, mv minimum square by r. This semicircle has the radius r, so m and m gets cancelled out. The v minimum comes out to be root gr. At the point B, if this cart has the minimum speed root gr, then it can easily complete this loop, this vertical circle. Momentarily the normal will be 0 here. Now if you check the formula of V minimum, there is no term of mass here, so the mass has no use. Answer should be A. But further I am deriving the things. When this cart is coming from A to point B, then the cart has lost the gravitational potential energy. Earlier the height was h1, now the height is h2. This loss in gravitational potential energy will appear as the gain in the kinetic energy, because the track is frictionless, there is no air resistance, so there is no loss of energy, means mechanical energy will remain conserved. What I mean to say, loss in gravitational potential energy should be equal to the gain in kinetic energy. Loss in gravitational potential energy should be equal to the gain in the kinetic energy. Now, how much is the loss in the gravitational potential energy? We can easily see. Finally, the cart is at this height h2. Earlier, the cart was at height h1. Earlier, this height was h1. Now, this height is h2. So the loss in gravitational potential energy can easily be obtained. This difference is h1 minus h2. So the loss of gravitational potential energy is mg h1 minus h2. And the gain in kinetic energy. Earlier the kinetic energy of the cart was 0. It started from rest. It was released at point A. Okay. The final kinetic energy of the cart we can write as half m v minimum square. So the gain in kinetic energy is half m v minimum square. V minimum we already know from the condition of the looping the loop. So putting up the data and cancelling that m here, we have g h1 minus h2 is equal to 1 by 2 v minimum square. V minimum was root gr. Agree with this? Now this 2 we can shift there, the g here and g there will get cancelled out. So here we can write the final expression. 2h1 minus h2 is equal to r. You get this? You do the square, then this square root and the square, they are eliminated. This G cancels out this G, and then R is equal to twice of H1 minus H2. This is the condition so that the cart completes the loop. Now, in all these conditions, whether we check the V minimum or we check this condition, the mass appears nowhere. So, we can say this mass has no role in deriving this condition. I hope you got the solution. Yet, if you have any doubt, please post in the comment box. If you have watched it up to here, please like this video, subscribe to this channel and share it with your friends. Stay awesome and thank you.